RIGOL's VSA, or Vector Signal Analysis application, extends the capabilities of the RSA5000 series to include complex signal analysis and demodulation. This ability makes it possible to characterize RF modulations, including QAM, QPSK, ASK, FSK, and more signals. Engineers can visualize and analyze modulations and error characterization, as well as constellation diagrams. The instrument's ultra-real technology brings advanced triggering, including sync and burst searches, to the VSA mode. This makes it possible to compare captures to known good data for bit error rate testing. For engineers testing and verifying transceivers and RF link devices, these digital demodulation measurements are an important bench test capability. Let's look at some digital demodulation capabilities in the VSA. In our digital demod menu, we can select a modulation format, such as QPSK. We're putting a QPSK signal into the analyzer that we generated in our DSG3000 series signal generator. So up on a 2.4 gigahertz carrier, we can see the constellation diagram, the spectrum, a symbol table of the data being demodulated, and a summary of some of the error conditions and characteristics measured in this signal. Here also in the measure setup, we can select between other modulations, QAM, FSK, ASK. We can set the measurement interval, points per symbol, symbol rate. Some of the other characteristics, more complicated, defined on a per modulation basis. All this data is being captured in real time using the ultra-real technology at the heart of the RSA5000. Because of this, we can also utilize advanced triggering capabilities with digital demodulation, including frequency mask, power trigger, and external triggering. Using the frequency mask, we can go ahead and set up a trigger based solely on when we're getting a signal in the main band here. We can edit this and adjust this as well.
Instead of the frequency mask trigger, let's add a burst to the signal coming out of our signal source. And now let's switch to trigger on a power trigger. Here we're triggering on a power trigger, but now let's go ahead and look at that burst. We can hit the trace menu, and here we can see the other options for our measurement types. There are 13 total options, including capture data like the spectrum, measurement signals like the the constellation diagram, reference signals, demodulation errors, our symbol table, our error summary, and our real-time trace. Here for this one, let's switch this to a time per symbol in the capture data. This shows the burst at the beginning of our sequence. And now we can see that we've really stabilized the data sequence coming out of that, because we're getting the same data pattern with respect to the burst. Now we can go back to the measure setup. And we can do a couple other things. Let's use our burst sync search. So we've already turned the burst on to capture that burst and trigger on it, as well as the power trigger. Now we can turn the sync search on as well. Here we've set it to synchronize to a pattern that starts with ones and zeros. That allows us to get the same data pattern with respect to the burst and look at a complete data segment. Now as a functional test, we can go one step further. Go back up and select a known data set. We can recall a data file we've already created. And now we can go in the measure menu and switch over to a bit error rate test. Now, whenever that burst triggers, it synchronizes to this set of bytes on the synchronization pulse and fills out the rest of the 200 bits. Now we can see that we're getting complete agreement on each bit to what we're expecting in the file. This is a great functional test, making sure our transceiver is putting out the right bit pattern. In addition, because of all the complicated setup available in this instrument, we can go further and go ahead and preset to some standard test elements. For instance, we can preset to a GSM pulse.
And then change the data being output by our signal source. Well, see, now we're looking at a totally different type of modulation. So a GSM uses different filter types and a MSK modulation style at a different frequency. But the instrument's able to preset to these standards so that GSM pulse and data can be easily identified. Similarly, we can look at wireless techniques like Bluetooth. With this Bluetooth data, we can see the FSK type modulation in the constellation diagram, the entirely different envelope in the spectrum, but still see the data sequence and the error summary coming through. All this customization allows us to really build a number of personalities for different common modulation types, but still have the flexibility to set your own modulation setup for whatever custom radio work needs to be done. The VSA application can be added to any RSA5000 Series real-time spectrum analyzer with a license code tied to the instrument serial number. Any RSA5 with up-to-date firmware can add this as one of the instrument modes. Once activated, it can be selected from the mode menu, just like with swept, real-time, or EMI. Vector signal analysis mode provides the ability to validate and debug custom and standard demodulations using constellation diagrams, spectrum, symbol, and error summary views. It can also calculate the bit error rate of known data segments. VSA uses RIGOL's ultra-real technology to take real-time debugging and visualization to the next level with detailed analysis capabilities for your complex signals. Find more information at www.rigolna.com or give us a call directly to discuss your RF applications.